guys, we're going to be talking about interior and exterior angles. So interior, just like when you talk about the interior decorator, that's the decorator for the inside of your house. So interior angles are going to be angles that are inside of our polygons. So polygon is just a shape that's closed in, okay? So if you hear that word, that's all that means. And then exterior is going to be outside. Now, basically what that means is that you're just going to extend one of the sides. So when the two sides come together, they make a vertex or an angle. And so you'll just extend one of those, not both of them. So let's take a look here. So the interior angle theorem says that the angle on the inside of a polygon is formed by pairs of adjacent sides. So that's that vertex we're talking about. The sum of those, okay, is going to be based on the number of sides for that specific polygon. So if the n is going to be the number of sides, so the sum, all of the angles inside are going to add up to be 180 times the number of sides, which is n, minus 2. So if I have a figure with, or a polygon with 5 sides, then I would have 180 times 3. So that's how I would determine the sum. So I can also go from there and be able to find out an x or something like that in our examples, and you're going to see that here. And then you also have exterior angles. Exterior angles are basically just formed when you extend one of the sides of the polygon. So again, just one of those sides. And then the sum of those, no matter how many sides it has, if it has 50 sides or 4 sides, the sum of the exterior is going to be 360. So just like a circle there. All right, so the first one is just pretty straightforward, and this is just being able to plug this into the interior angle theorem. It says, what is the sum of the interior angles of a polygon with 12 sides? That's also known as a dodecagon. So therefore, I'm just going to plug this in. So I know that the sum of the interior angles is going to be equal to 180 times 12 minus 2. Okay, so that's going to be the sum there. And then I would do 180 times 10. That's what 12 minus 2 ends up being. And then I'm going to get 1,800. So that would be the total inside angle. So you can think of that. That's going to be also, if you think about like the more sides that you get, almost obviously you're going to get closer and closer to a circle. So those angles are going to start getting wider and wider and wider and wider because it's going to almost start opening up almost to a circle. Okay, so the value of a we're gonna have to talk about how many sides are on this pentagon or are on this polygon, and then we're going to have to use that to be able to find the value of x here. So let's see here. We have a 5-sided figure that's called a pentagon for this polygon. So what we'll do is we're going to find out how much the inside angles are all going to add up to be. So I'm going to have 180 times 5 minus 2. Always subtract 2. That 2 stays there. So that would be 180 times 3. So we're going to have 540 degrees. So all of those inside are going to add up to be 540. So before we did this a lot with triangles. So that was always 180. Well, now that we're throwing in some more polygons, we're going to have to change how much it's going to be equal to. So I'm going to have 112 plus 87 plus 85 plus 123. And I'm going to go ahead and add my 12x plus 37. Whew, no, I almost don't have enough room. Is going to be equal to the inside sum, which is going to be 540. Then I'm going to go ahead and add all of these numbers together. And therefore, then I will basically end up with a 2-step equation. So when I add all those up together, I get 444. So it's going to be 12x plus 444 is equal to 540. And then I'll solve this like a 2-step equation. I'll subtract 444 from each side. And so 12x is going to be 96, then I'll divide by 12 on each side, and so x is equal to 8. So it didn't ask for the angle measure there, it's just asking for that value of x. All right, in example 3, this is an example of exterior angles. So these angles are taking one side of that vertex for this polygon and extending it out. So remember that this doesn't matter how many sides there are. There could be 12 sides, or there could be just as few as 3 or 4, and that's still going to be 360. The only thing that changes is the inside angles. All right, so what we have here is we have a couple of values here. Remember, they're all going to add up to be 360. So I'm going to add all these up. So I have 85 plus 5a plus 20 plus 10a plus 3 plus 2a minus 3. And that's all going to be equal to 360. So I'm having to move that over here on this side. So what I'm going to do is go through and add my a's together. So combining like terms, add my a's together, and then add my constants together. So I have 360 is going to be equal to 17a. And then I'm going to add all the constants together. So it's going to be plus 105. And then I'm going to subtract 105 from each side. 255 is equal to 17a. And then the last thing you do is divide by 17 on each side. And so 15 is equal to a. And that's what we just are trying to find the value of a, not a specific angle measure. But you could be asked that, and you just replace that a with 15 and figure out that angle measure. Okay, on this last one, we are going to have to figure out the angle measure of J. But there's a couple of steps we're going to have to do first. You'll notice that J has a Y with it. We also have another term with a Y in it. So we're going to have to do this summation thing and solve for Y, and then plug that Y back in and find J. Now, I need to figure out how much does the inside add up to be. So I need to figure out how many sides there are. I got six sides. So therefore, I'm going to have 180 times 6 minus 2. So 180 times 4, which is 720 degrees. So all of those are going to add up. All the inside angles, interior angles, are going to add up to be 720. So I'm going to have 720 equals, I'm trying to write a little bit smaller. I'm going to start with G. So 101 plus 2y plus 12 plus 3y minus 7 plus 150 plus 146 plus 118. All right, so long polynomial there. I'm just going to go through and get my like terms together. So get my y's together and get my constants together. So I end up with 5y plus 520. And then I'm going to subtract that 520 from each side. And I get 200 is equal to 5y. Then divide by 5 on each side, and y is equal to 40. Now, I'm not done because I'm going to have to replace that y. It didn't ask for the value of y. It asked for the measure of j. So I know that y is 40, so I'm going to replace y with 40. So I have 3 times 40 minus 7. So 3 times 40 is 120 minus 7, and that's going to give me 113. And that's going to be the measure of angle J there. So we have a couple of theorems going on here. We have that interior angle theorem. That's going to be 180 times the number of sides minus 2. And then we have the exterior angle theorem, which is all of the exterior angles are going to add up to be 360. So that's it for these two angle theorems. We're going to continue looking at polygons and more specifically quadrilaterals as we move forward.